We're given f prime prime x is equal to 48x squared plus 2e to the power of 2x minus 1. So in order for us to get an expression for f prime x, we're going to let it go through a process of integration. So integrating 48x squared plus 2e to the power of 2x minus 1 will give me f prime x. So let's integrate this. This will be 48, then x to the power of 3 divided by 3 plus 2, then this will be e to the power of 2x minus 1 divided by 2. And let's not forget plus c. So this is equal to 16x to the power of 3 plus e to the power of 2x minus 1 plus c. We need to solve for c, and according to what the question says, at the point when the y coordinate is equal to 1/4. At this point, the normal is x is equal to half. So in fact, we know that at this point here, the coordinates is half 1/4. So according to the question, x is equal to half is the normal, and this is actually a vertical line. If this is a vertical line, this implies that the tangent is going to be a horizontal line. In fact, we know the equation of this horizontal line. The equation is y is equal to the y coordinate of this point, which is 1/4. And what's so special about a horizontal line? The gradient is 0, which means that f prime x is equal to 0 when x is equal to half. So making use of this, we're going to try to find c. So f prime of half when x is equal to half, the gradient is equal to 0. So f prime is equal to 0. So substituting half into here, we have a 16 times half to the power of 3 plus e 2 multiplied by half minus 1. So e to the power of 0 plus c, this is equal to 0. This we are going to be getting a 2 plus e to the power of 0 is 1 plus c, this is equal to 0. So c is equal to minus 3, and now we have our expression for f prime x. It is 16x to the power of 3 plus e to the power of 2x minus 1 minus 3. The expression of fx will be found by integrating f prime x that we found in the previous part. So it is going to be integrating x to the power 16x to the power of 3 plus e to the power of 2x minus 1 minus 3. So this is equal to 16, then x to the power of 4 over 4 plus this will be e to the power of 2x minus 1 divided by the coefficient of x, which is 2, then minus 3x plus an arbitrary constant. I'm going to go for d since previously I've used c. So this is equal to 4x to the power of 4 plus half e to the power of 2x minus 1 minus 3x plus d. And to solve for d, we are going to make use of the fact that we have found out that half 1/4 is going to be a point that lies on the graph of y is equal to fx, which means that f of half is going to give me an output of 1/4. So replacing all this x by half, we have a 4, then half to the power of 4 plus half e to the power of 2 times of half minus 1 minus 3 times of half plus d, this is equal to 0. So this is equal to 1/4 plus half times 1, this is going to be equal to half, minus 3 times 3 times 1 over 2, it is going to be 3 over 2 plus d, this is equal to 0. This will help me to find d. D is equal to 1. So the expression for fx will be 4x to the power of 4 plus half e to the power of 2x minus 1 minus 3x plus d, which is plus 1. In part 3, we're going to be looking for the equation of a tangent. And according to what the question says, the tangent is going to be on the graph of y is equal to fx. And specifically, it is going to be at the place where the graph is going to be cutting the y-axis. So we are looking at the point here. So the tangent is going to look something that is like this, which means that the y-coordinate of this is an unknown, but the x-coordinate is going to be 0. So the first thing that we want to do is to find this y-coordinate of this point, and the next thing I'm going to do is to find the gradient of the tangent that is at this point. So when x is equal to 0, let's find the y coordinate. The y coordinate will be f0. Since this graph is the graph of y is equal to fx. So this is equal to 4 times of 0 to the power of 4 plus half e to the power of 0 minus 1 minus 3 times of 0 plus 1. And the y coordinate is going to be equal to 1 over 2 e to the power of minus half plus 1. And this is 1 over 2e plus 1. So the y coordinate, now we know, it is equal to, let me write down here, 1 over 2e plus 1. We need to find the gradient of the tangent, and that is dy dx. And dy dx is f prime. So f prime 0 is going to give me the gradient at this point. So f prime 0, making use of what we have found previously, is going to be 16 times 0 cubed plus e to the power of 0 minus 1 minus 3. So this is equal to e to the power of minus 1 minus 3, which is equal to 1 over e minus 3. And now we are ready to find the equation of the tangent. So for the equation of the tangent, let me put it here. So equation of the tangent at this point that the question has described to me, it is going to be y is equal to the gradient. The gradient is this. So it's 1 over e minus 3x. Then plus the y-intercept. The y-intercept is 1 over 2e plus 1. So this is the equation of the tangent, but the question requires us to manipulate this further. So to manipulate this, let's expand this. So y is equal to 1 over ex minus 3x, and this plus 1 over 2e plus 1. And if I were to bring this and this across to the left-hand side, you'll have a y plus 3x minus 1 is equal to 1 over ex plus 1 over 2e, because we do see this as part of what the question wants us to be showing. Then multiplying throughout by 2e, then I will have a 2e y plus 3x minus 1 is going to be equal to 2x plus 1. And this is what the question have been asking us to show.